Climate lecture number 3. I've got 3 climates I'm going to do in this lecture, and I want to show you the influence of warm versus cold offshore currents on summer precipitation. Climate number 6. I've got this star. This is an important one because this is our climate here in Louisiana in the southeastern United States. It's called the moist subtropical climate. Now again, remember the names of these climates. Moist means a rainy climate, and subtropical is referring to the temperature regime, and I'll define subtropical in just a second. Let's start with the temperature regime. I want to do summer. Right? So here we've got hot, humid summers. We know that, right? But just kind of take a look at the average summer temperature here of the hottest months, 80 degrees, hot and humid. And do you remember our first climate, the wet equatorial, where it averaged 80 degrees all year long with no annual temperature range, and it was hot and humid? So just think of our summertime temperatures and you get some idea as to what it's like in the wet equatorial climate. Right? Now the other thing is what subtropical is. We've got mild winters. Now the definition of subtropical is that the temperature of the coldest month, usually January or December, has to be above freezing. And so with this climate, we're usually somewhere averaging about 50 degrees for our coldest month. And that's what's going to differentiate the climate just to the north of us, say in the northeastern United States. It's a mid-latitude climate. It's cold with snowy winters. Definitely we're going to see the average of the coldest month well below freezing. Now, let's move on to the precipitation. We're going to be adding a new pressure belt. Our next pressure belt around 60 degrees north and south latitude. We call it the polar front low. Front. We know now what a front is exactly. It's a weather system called a wave cyclone. So that's what these icons are here. This is the warm front, the cold front, the center of the low, and all the isobars. All right. It's a moist climate, a rainy climate. And so, as you can see, we've got ample precipitation in every month. And our climate station here in Charleston, South Carolina, gets a little bit less precipitation than we do. Well, a little bit less. We get about 20 inches more. Now, the important thing about this climate are the two mechanisms producing the precipitation throughout the year. Now, in winter time, our precipitation is in the form of frontal precipitation. Wave cyclones start to make their way in subtropical latitudes. Now, this is one of those climates where you have to think about the shifting pressure belts. Now, if you think about it, usually in about October, we start to get our first cold front. And then they start to come more frequently and more intensely. And you're like, why all of a sudden in October do we get our first cold front? Well, during those summer months, those wave cyclones have been far north of us. They've been up in the northern tier of the U.S. or in southern Canada. And now as the subsolar point is moving into the southern hemisphere, all of the pressure belts are shifting southward, meaning those wave cyclones are shifting now southward into subtropical latitudes. Now, during summertime, we get afternoon thunderstorms, convectional precipitation. But take a look at this. We're dominated by the desert maker, the subtropical high. And we actually get more precipitation during the summer months. Well, this is where we get into the importance of offshore ocean currents. Now, we talked about the gyres that are set up by the subtropical highs. And now we made a very important conclusion about the gyres. If you are on the east coast of a continent, you should always expect a warm offshore current. Now, if you're on the west side of a continent, you should always expect a cold offshore current. So these warm and cold waters definitely affect the precipitation regime. Now, this climate, as we're going to see, is always on east sides of continents. And so we're going to be affected by the warm ocean current, unstable side of the subtropical high. And so if we're thinking about the eastern U.S., here we've got a nice map of the summer enlargement of the Bermuda High. And here we've got the winds in green, the outward blowing winds, and then the gyre being set up in a clockwise manner. And so what we wind up with is a warm ocean current, the warm Gulf Stream, moving along the eastern seaboard of the United States. Warm water means warm, moist atmosphere. And once that warm and moist air from the ocean moves onshore onto the heated summer land, it's going to rise, adiabatically hit dew point, and create afternoon thunderstorms. So then, of course, on the west sides of continents, and we're going to be talking about that in our next two climates, we're going to have cold ocean currents, cold water, chilled atmosphere, sinking stable air. So we have desert over here in the Sahara Desert. So let's take a look at the world locations of this climate. Now, in order to find the moist subtropical climate, you've got to be on the east side of a continent in subtropical latitudes. You've got to be on the east side to get a warm ocean current from that subtropical high gyre. Definitely, you're going to find this climate in Louisiana and the southeastern United States, for sure, and there's Charleston there. Right? You've got to go all the way around the world, right? To China to get another warm ocean current. It's called the Warm Japan Current. Now, China is a very large country, but same size as the U.S., really. And so you're going to find the moist subtropical climate in southeastern China. And this is where the location of Shanghai is here on the coast, and then in the southern coast, Hong Kong has this climate. In the southern hemisphere, around 30 degrees south, the country of Uruguay, which is kind of a rounded country. And actually the climate extends a little bit into Argentina, the capital of Buenos Aires. So really Buenos Aires has a very similar climate to New Orleans, just reversed. Now you don't find the moist subtropical climate in Africa. Africa is what we call a plateau continent, very high altitude in general. The average elevation of Africa is about a mile high. So that kind of changes the climate mechanisms. It makes things drier. So really southern Africa is really dominated by dry desert climates, of the dry tropical, dry subtropical in the Kalahari Desert there. And our final major world location is in Australia. And again, mostly desert, but there are some other coastal climates that we're going to see. And in fact, along the southeast coast of Australia, we've got the moist subtropical climate. Now, Sydney, here's 30 degrees south here. Sydney, the largest and most famous city in all of us in Australia, is at 30 degrees south latitude, and so Sydney has the exact same climate as New Orleans, right? But only the seasons are reversed, of course. And so summertime is hot and humid with convectional thunderstorms, and then in wintertime the rain comes in the form of frontal precipitation from wave cyclones. Let's put this on the map, all right? Okay, yeah, so what we're going to do now is just kind of fill in the eastern half, right? We've got the warm ocean current creating moist climates. All right, so we've got it here in the northern hemisphere and in the southern hemisphere. And we needed to add our next pressure belt, wave cyclones or the polar front low. And again, this is definitely one of those climates where you've got to consider the shifting pressure belts. So I've got my winter arrow, bringing wave cyclones into our subtropical latitude during the winter months. All right, I've got two more climates that are pretty much related, and they're West Coast climates. And again, think of the United States. We're going to do the climate of California, and then we're going to do the climate of the Pacific Northwest. All right. Now, climate number 7 is called the Mediterranean climate, and it's named after its most famous location, land surrounding the Mediterranean Sea. But of course, it is found in other world locations like, California. And that's where our climatograph is coming from, Monterey, which is located just south of San Francisco. Now, Mediterranean is a sea, all right? And so that's kind of the key term. Mediterranean is an ocean sea, and so we're going to have the marine effect on this climate. All right, and so take a note here. We've got a relatively low annual temperature range for this climate. If you think about California, it's right along the west coast, and you've got the westerly winds pumping in that Pacific air all year long. And so you've got a very, very mild climate. And people like the climate, the climate of California really is one of the nicer climates Summertime temperatures, look at this, are very mild. Typically the highs are in the 70s. And then, wintertime temperatures are also averaging above freezing. So it's kind of a mild, pleasant regime. So it's almost perfect. Now, of course, I mean, they have heat waves in summer and, occasionally they've got freezes in winter, maybe a little bit snow. But this is the average. Look at the range. So it's kind of a pleasant thing in terms of temperature. Now, the precipitation regime, yes. Okay, that's summer is dry. So if you kind of take a look at the icons, it really is the same that we just saw for our climate, the moist subtropical. The big difference is that we're on the cold ocean current side. We're on the west side of a continent. And so you're going to wind up with dry, stable conditions, really severe summer drought. And so usually, I mean, my God, Jesus, April is getting about just over an inch. May, June is July, August, September. How many months is that? 1, 2, 3, 4, 5, maybe 5 or 6 months of drought conditions. So it's very, very dry. So yeah, and that's due to, so dominated by the subtropical high, but we're on the west side, stable side of sinking air. And then, similarly to our climate, winters become rainy as the wave cyclones now shift southward following the migration of the subsolar point into the southern hemisphere. And so frontal precipitation begins in October, just kind of like here, and then kind of intensifies on average throughout the winter months. All right, the location, right? West coast of continents. It's got to be a west side of a continent to get that cold offshore current creating summer drought. Now, this climate is very, very small in distribution. And actually, the next climate, too, is very small. And so we're going to be looking at climate number 7, shown in olive green. And then our next climate will be moving on, and it's going to be in kind of blue. But they're very, very small in distribution. All right, major world location, California. All right, and there's where Monterey is. And then, of course, we've got mountain ranges creating orographic precipitation, particularly during the winter rainy season. And so we're on the west side of a continent. And then, of course, the Mediterranean lands of Europe, of the Middle East, Israel, and then some very narrow coastal locations in Mediterranean Africa. In the southern hemisphere, we've got this climate, again, very small in distribution. In middle Chile, right here, where the capital is, Santiago. Now remember, it's a nice climate. And so, of course, this is where the population center is going to be. It's middle Chile. You've got northern Chile. It's an elongated country. It's about 3,000 miles long and only about 90 miles wide. And so northern Chile starts somewhere around 20 degrees here. And then you get into middle Chile where you find this climate. And again, you've got a cold ocean current. It's the cold Peru current bringing cold Antarctic waters. Cape Town, South Africa, all right, is another location, kind of west side here, dominated by a cold ocean current coming from Antarctica. It's called the cold Benguela current. Another major location, here we are back in Australia with some of the coastal fringe climates. Perth, Australia, largest city, on the west side of Australia. And also Adelaide here is another city. It has this nice, beautiful Mediterranean climate. And so let's plot it. Okay, it's a very, very small climate and distribution, so I've kind of put it to 45 degrees north and south. Now I've added my next pressure system, polar front low, but we know them more specifically now as wave cyclones. And so what we've got to do then is, think of winter shifting south of all of these pressure belts. And that explains the movement of wave cyclones into our latitude range. All right, the last climate that I'm going to do in this lecture is called the marine west coast. Marine climate. What is the marine effect on climate? And well, west coast. Makes it kind of easy for you to remember where they're found. And so this climate has the classic marine effect on climate. Now, what that means, classically, is that you can be at a high latitude location and have a surprisingly low annual temperature range. Now, normally it should be very, very cold in wintertime. Because of the marine effect, you're going to wind up moderating temperatures. So our climate station here, representing the marine west coast, is up in Canada, Vancouver, British Columbia. And what do you think about Canada? I mean, the temperatures of winter should be much colder, all right? We're averaging above freezing. And so Vancouver is located just north of Seattle, Washington, all right? And so you've got, it's a coastal location. So you've got the westerly winds pumping in that Pacific air, keeping things really quite mild. Look at that annual temperature range. I mean, I think it's actually about less than ours, or just about the same as our temperature range here in our moist subtropical climate. So, cool, mild summers and moderate winters, not extreme at all. All right, it's rainy all year long, ample precipitation in every month. All right, the main influence is wave cyclones pretty much all year long. All right, and you get abundant, heavy precipitation during the winter months. Now, in summertime, you still get the wave cyclones moving through, but a little bit less. If the subtropical high really enlarges, and in this case it would be the Hawaiian high, it'll enlarge, further north and to this latitude range and block the wave cyclones from coming through. It'll block them and moving them northward. And so you tend to have a little bit of a drier season in those years when the subtropical high enlarges. And so you get high annual totals. Yeah, and so, so you're going to study number 7 and number 8 together, the last one, because they're very similar, really, just with the exception of the subtropical high being a lesser influence, right, in some years, and more precipitation in this climate. Okay, and so this is how you study them together. So we've got the map, we've got the marine west coast shown in kind of a blue, and you're always going to find the marine west coast poleward of the Mediterranean. Like I said, that's why you study it together. So you always find it poleward. It's always a higher latitude location. That's what poleward means. So in terms of major world locations, it's going to be the Pacific Northwest of the U.S. So Portland and Seattle, and then there's Vancouver, British Columbia. And again, of course, these are the mountains, the Cascades, and so you're going to have again another orographic effect. But it's the westerly winds that are really important in bringing in those wave cyclones in winter time. Okay, yeah, so that's poleward of California. Now let's move poleward of the Mediterranean lands. Western Europe, Ireland, British Isles are famous for this climate. Mild all year long, but quite rainy. Summer's a little bit drier. So if you ever go to Paris or London, it's classic, right? It's kind of the same as Seattle or Portland, right? Kind of rainy with frontal. But those fronts kind of, slow down again in summertime, like I've said. All right. In the southern hemisphere, you're going to find this climate poleward, towards Antarctica in southern Chile. You don't find this climate in Africa, right? We've ran out of land here, all right? And so, if we had land, if Africa extended, further south, we'd have wave cyclones moving on through. But we ran out of land here. Now, we do have a little bit more land here in the austral realm. In southern Australia, this is where Melbourne is. Kind of a rainy climate. And then Tasmania offshore. And actually, this marine climate is really very, very famous in New Zealand. Mild temperatures all year round, and a lot of precipitation, frontal precipitation in the westerly winds. And again, kind of moderating out in summertime, maybe a little bit drier. Now, the other thing that I want to say is, look at this. We ran out of land in the southern hemisphere. This is the final climate for the southern hemisphere. It's because either the land ends or the continents taper and we have no more land. No more land means no more climates. And so what we're going to do for the remaining climates, except for the last two, is we're going to be talking about in northern hemisphere climates. They're all going to be continental type climates with large annual temperature ranges where the continents are very large and they heat and cool dramatically. All right, so let's put on our hypothetical continent, climate number 8, marine west coast. All right, and so here we've got, I put in our westerly winds, bringing in, abundant wave cyclones and all that marine effect here. And so we're kind of going up to this 55 degrees in north latitude, so really quite mild. Winters are really not too bad considering such a high latitude location. Now, in the southern hemisphere, okay, maybe the continents taper somewhere around 60 degrees south latitude. Now, of course, my marine area, right, is a lot larger than reality. But it just has to do with the way I made, I made my hypothetical continent because I had to have some room to put in the names here. But again, we've got the westerly winds and the wave cyclones dominating this climate. End.